So let me brief about some basic. So what are the sources which I read for? So for placements, basically for apti, Arun Sharma. This is a book. Next, for puzzles, you can watch videos on YouTube, like some show you some. I think this very good, and some other channels are there, so you can watch on those. Next, puzzles like example. Actually, this is not the way. Example like this. This is a problem statement, and what is the answer? Like that. Those are the basic puzzles, and they will be asked in interview also. So better you cover. If you suppose if you cover once, then you can remember uh, revising twice or something. You can definitely hold in. You can have a much better idea. So basically, these are the repetitive type questions. So one can ask within these 60 70 or something 100, around 100 puzzles are there. So those are enough to cover. Next, after FT, next go for C language. So books are not that I suggest for. So better you read C language and data structure at website like Geeks for Geeks and India Geeks and some other hacker anchor and something. So majorly you should focus on practicing and small codes which I showed another video. So next, computer architecture, if you want to learn, then NPTEL will be better choice. So like actually major concepts are there in computer architecture like pipelining or something. Let me show you. Here they did not give that, so we can focus on pipelining and something throughput or something. Those type questions are there, so definitely learn those. Next, if you want to learn, then learn C++ also, and Java is not that I recommend for us VLSI subject students. Next, physical design. VLSI physical design is not important by the way, so this is extra one. So next, if suppose for VLSI, it will be better you cover this subject like ADIC, and what this is architectural designing and IC. So basic what they cover here it is. This is covered by this professor Hatai. So he covers like let me show what exactly. Basically, in that there are algorithms or something like or you can read this PPTs by PPT by Parhami. So these are the chapters, and some basic major concepts are like what exactly, how exactly we do in this side. Actually, there are concept means algorithms, simple algorithm, how we proceed and how we write something. So basic these are the how we do multiplications like carry look ahead adders and basic countings and other like, let me show you stage by stage how many adders, how many and gates are required, and how we follow the paths. So if suppose example in this is a sign magnitude adder. So basic blocks are, this is system level type designing, means analysis. So basically a controller controls the things, and adder, and to store these values some register will be there, and this will be the path this is a major control, and these are the operators like some you want to add, then you can feed two values, and by controlling through this you can get whatever you want to, like adding or subtracting. Next, that is basic idea. Next, how multiplications are done. There are many ways to do that, so you have to learn this. So in interview also they can ask, they generally ask this, how means different methods are there, so learn those also. Let me see example. So actually main aim is go for highest accurate and high speed circuit. So that's why um, many different analogies and methods are came into. So you have to learn some this. This is by this is the PDF for PPT something. So this one is for ADIC. ADIC means architectural design, okay, or book by himself only. Okay. This is the NPTEL one. You can download these all from NPTEL site. Next, for digital, uh, synchronous logics, like exactly in this. And get basics. After that, some example. Suppose some circuit will be given, and you have to write get into what exactly happening there, like duty cycle, or some what type of flip flop it is, and what type of like clocks, means counters with something. Okay. Let me show you example. This is, you can, all these are available on internet. So by Anand Kumar book, or NPTEL state machine. NPTEL, it is state machine is much more important by the way. State machine, like so this is a problem solving type. Suppose you want to detect something in this, then how exactly you write a code, and how exactly uh, the, what do we say, using gates, this is circuit level implementation, how you do that. This is idea. So it will be better you learn state machines also. These are majorly I like this. So important also by the way. Next, or something, I recommend this book. Read 11th chapter or something. In that, sequentials are in this book by 7th chapter or something. Okay, next, digital VLSI PPTs by Rabe. This is the most important by the way. So cover of total, and you can watch his videos on YouTube. So better go through that. So basically here he explains like basic major ideas from inverter to different technologies like CMOS, BiCMOS, and logical efforts. This is total MOSFET detailing and something. So there are something around 400 PPTs are there. You better watch videos of them on YouTube. Next, books for digital VLSI. Some Hodges are is also a good book. I don't recommend Rave's book by the way. You can watch his videos and note the things better. And this is a better book. And this I think this PDF is good by the way. This is book. Next, I think this one. This is also book by the way. So next, digital IC. This is digital ICs. You can next digital IC design, system design, not important either. Low power VLSI. So low power VLSI problems like latcher problems or something. I think this is a NPTEL videos, NPTEL videos PPT. So in this he explains what exactly. So I definitely recommend this YouTube video to watch. So content outline for his is, uh, these are the basic on MOS, what exactly he goes to. Next, inverters, MOS inverters. I mean some MOS like NMOS, CMOS, PMOS inverters. What exactly disadvantage and advantage of each one of them. And next, so super buffer inverters, buffers, and CMOS inverter. I mean by CMOS. Why we go for them, and sizing. These are the major concepts. Next, next combinational circuits. Like if suppose you have a combinational circuit like AND or, so how they are implemented, how you can implement those circuits. So in this section, third lecture or something, fifth lecture, fifth part or something, he explains that. So next, this one is important by the way. These can be asked in interview also, like what exactly is sub threshold and gate leaking, and what are the problems happening in the uh, digital circuit, like dynamic power dissipations also. Next, this is from here, it is low power VLSI, fifth and sixth and seventh, eighth. Basic up to fourth, it is basic CMOS. Okay, it is important one by the way. In general, everyone whoever teaches CMOS, explains these concepts, so better you cover in depth. Next, these are the concepts which I written, means major headlines, like basics of CMOS. Here he explains basics, and next by CMOS super buffer, and dynamic CMOS. What exactly, why we go for dynamic logics, and okay, those are the major concepts in dynamo CMOS logics. This is a bit important. I referred it as important by the way. So nothing special in this. This is just adding a inverter in this. You can make a circuit and dynamo logic. Okay, next Nora logic. Next Moro delay. This is important by the way. You definitely learn this. Past logics, past transistor logics, and RAM switches, and scaling. After this, it is from here. It is scaling, means low power circuits. How exactly they lower down the supply, or techniques which improve our circuit supply, means with less supply only we how can we operate system circuits. Okay, next, these are the techniques in this they he explained that. Next, low power VLSI is important by the next books now. I don't think it will be better to waste time on reading books. If suppose you want to read, then you can. mm, Next, and digital VLSI NPTL it is, and this is the same VLSI, low power VLSI which I explained, and this is very log by Indra and Sen Gupta something, IIT Kharagpur sir. And okay, Verilog is important by the way. You go through that NPTL video. After that, you practice codes on, like I show you EDA board, EDA playground. This is the website which I used for coding Verilog. So this is the interface. In this is a test bench and design code. After this, you can run this code. Like you have to choose which one you want to, like system Verilog or something. Okay, next here it is. I think they changed the interface. No, let me see. If suppose you want to see the waves, means output waves, you have to pick this. Next, this is these are the simulators. So generally for Verilog it is better you choose these three. I chose, means I whatever I know I am explaining, that's it. Next, this, and after writing codes you can simulate this, run this, and you can log in on this website also. Next, Verilog app, and next Razavi. This is my suggestion. I would definitely suggest you better watch Razavi's uh, video lectures, like Razavi. electronics one, and electronic one is not that important. Means it is like basic one. EDC, it covers EDC also in this, and this will be better. You you must at least to go through. I think I have the PDF of videos, screenshot of the videos, something. Uh, Razavi, this one. So you better note this all. So 45 lectures or something. So these are the major important by the way. So explains basic very neatly and good good explanation is. I I like this method. This method means this one. This what is calculating GM of a circuit. A circuits a system, like if suppose a system is there, then how you calculate its GM. I show you this one. This method is important by the way. It helps a lot by the way. So you watch this. So I don't explain this now. So you better watch his videos. He covers lot whole more topics from basics to small signals to. So differential is you better concentrate. You once go whole chapters on that. Next, mixed signal. Next, RTL logics. I think these are the important by the way. I did not go through this very much, but important by the way. Like this is the NPTEL lecture. This I recommend this all in ending by the way. Means after you've done, you have gone through all the other things, then you go through this. What means? I think this is the fault detection, right? This is major concept. Fault detection. How exactly you detect a fault, whether in a circuit, whether a circuit is shorted or something, whether it is not working or not. So how you uh, know whether something is stuck and how you rectify that. Okay. Or you can watch videos, YouTube videos. Some videos are there. Next important RTL logics means this is by RTL means they here it is like a uh, ST only state. Next, this is I think someone's. I think this is found on internet, so you better go through setup and hold times and something. And this is Elmore delay. Next, some major concepts that you better read through this. This is by this type this on internet, so you can get. Next, sensitized path RTL. These are the major concepts. They definitely ask questions from these. Next, TLST. This is important by the way. So you read this on VLSI experts website. These are the PDFs. PDFs means this is website HTML file only. Next, VLSI expert screenshots. This is the video, and they explain on YouTube. You can search this. This is the name of the lecture. It's no lecture video. Next, what this is. So this was an example by the count number of. This is a question by the screenshots. This is important, and this one is major important. This is for C language, and this is by them. We are experts. Okay, next I'm giving a overview by the way. Okay, next Verilog sources. Verilog by NPTEL is it is okay, but you go through that, and you practice on Xilinx or that is Xilinx, right? uh, Next, better practice simple major questions, means basics how to write a 4-bit adder code, and some major concepts. Let me show you major concept like 0 to 7. Code for these are the lecture screenshots. Next, after that, very long. This is not important by the way. ASIC designing is important. Better you cover basics, means basic ASIC design, how exactly ASIC design flow is, and what are the steps, and next ASIC and other different methods are there. So those we better cover once at least. This one is next. We get interview questions. So basic questions are there. Okay, these are the sources. Okay. Next, that's it for this video.